This is going to be a slightly different talk, I think. Well, thematically, obviously, this is about CPR and how people train CPR and learn CPR. And what I'm going to try and do is give you kind of an overview of a line of research that we've been engaged in for a couple of years, rather than focusing on one or two very specific questions. So this is going to be a bit of a whirlwind tour in which I'm mostly going to focus on how we can move towards personalized CPR refresher trainings. And this is kind of interesting for multiple reasons. It's kind of a very interesting collaboration between researchers at the Air Force Research Laboratory, a kind of joint venture between the American Heart Association and a company that they've set up to study this kind of training. It's called RQI, and some researchers at the University of Groningen. So this is kind of like really a mix between like cognitive scientists and cognitive modelers, kind of going out into the real world and affecting training there. All right, so let's get started. Well, I wish this would be the end of the story, right? Like medical professionals should know this, and it would be great if we went to a hospital and we tested some people and they were all good at this and we could just end here. But obviously, they're not always doing as well as we would like them to do. So the policy change that has been mandated because of these findings is that medical professionals need to go through regular trainings and refresher trainings to sustain the skills that they have acquired at some point in the past. What is cool about this is that these trainings are performed on these mannequins that you can see here, and they collect a lot of data. Right, there are a lot of sensors in these mannequins, everything's stored. That's, of course, fantastic for people like us. So really the high level goal, just to kind of provide you the context here and state it very explicitly, is that what we want to get to is that when people come in for these trainings, that they perform consistently, that they're proficient at the skill. And what makes this challenging is that this is such a rare event. Right. So this isn't an experiment where someone goes through, what was it just now, 96 trials, right? Like this is very rarely done and hopefully never actually used in practice, right? That would be ideal, not true, unfortunately. But so let me tell you a little bit about like how this training is currently done so that you have some context for this. So what they're currently doing is what they call high frequency, low dose training. So these are quarterly trainings where people come in on these mannequins and practice. We're looking here because we're working with the RQI folks on people that perform hospitals that are part of the RQI system. They have these mobile stations that people can wheel out and do their training. And specifically, they're training 4 separate skills. So what people will do is they will practice the adult compression. So that means they're using the adult mannequin and they're doing the chest compressions that you can hopefully kind of see in the bottom corner here. I'm kind of in the way for some of you, I guess. They're also doing ventilations with the bag mask on the adult mannequin. And then they're doing the 2 equivalent skills on the infant mannequin that you see. Now, to be compliant on the skill, right, this is part of the job of these people. They need to be compliant in the skill. And what that means is they need to record 1 attempt with proficient performance per quarter, per skill, right? Quarterly trainings, 4 skills. And proficient means that on a scale from 1 to 100, they need to get a score of 75 or higher. Right, so that's what these people need to do. A critical aspect of this is the role of feedback in this training. And this is something I want to highlight here because I think this is where cognitive science insights are particularly relevant here. So when people do these trainings, they do 2 distinct type of events that they go through. The most common one is what I will here just call training. And that's basically what you see these 2 individuals here on the slides do. They're getting real-time live feedback, also real life actually, feedback on these computer screens, right? You can see while they're performing the skill, they're looking at the screens, right? So they're checking, are my compressions deep enough? Am I blowing too much air into this mannequin? That kind of thing. Obviously, the people that are building these systems have spent a lot of money on developing these feedback mechanisms that are adaptive, that give you audio cues, you're going too fast or whatever it might be, right? So they're really proud of this. So every occasion, occasionally, there's a second type of event where people basically come in and the feedback is turned off. and you're just given the mannequin, you're supposed to perform the skill. The scoring and everything else is completely the same, right? It's just there's no live feedback, basically. The training really just mandates, the way that the policy is implemented, that people need to record one attempt of 75 or higher, and it doesn't matter whether the feedback is on or not, right? So the default behavior would just be everyone does it with a feedback, come in, do the compressions, okay, you're good. So what they did is they mandated basically that there's one baseline event per year. So one time per year, they come in and they do the task without feedback. And this is basically the first time someone comes in and signs up for the system and is part of the RQI system. They start with the event where they have no feedback on. And then the following 3 quarters, the feedback will be on. And then the 5th quarter, right, like a year later, the feedback will be turned off again. This is kind of an interesting scenario for us because it allows us to kind of look at the impact that the feedback has specifically on the performance. And what you can see, let me quickly walk you through this. Do I have a cool pointer? Yes. So what you see here down here are the 5 quarters. The first and the last quarter are the ones without the feedback on, the baseline events. And then what you can see is the 75% performance threshold. So you should be on top of this to be proficient. And you can very clearly see this inverted U shape, right? People clearly perform better when the feedback is on. But most importantly, quite a few people actually fail when the feedback is off, even on the 5th quarter, which means they've already gone through a year of this training. And this is on top of, like, these are people that are already working in hospitals, right? These are not novices. And kind of, I guess, the higher level goal of what we're doing in general is we would like, I don't care that much about the performance in quarter 1. The point of the training is to improve the performance, right? Which seems to be working really well. But then I don't want to see that drop off as soon as the feedback is turned off, right? Like, that's kind of the high level goal here. So you might ask yourself, why is this a cognitive science kind of issue? I guess I don't have to really convince anyone in this room that we can be helpful in these kind of settings. And there is a lot of research about designing these kind of trainings and how to make them effective. The reason that the AFRL folks are involved and the cognitive scientists that they employ is specifically that they have done a lot of work developing computational cognitive models of learning and memory and forgetting over time. I won't have too much time today to kind of go into the details of this model. The details are described in these 2 papers. The model that we've been developing and using in a lot of the applied settings is called the predictive performance equation. And it has a very kind of solid track record of both explaining data, like experimental data that are from spacing studies and that kind of stuff, and predictive utility in applied tasks. Some of these tasks are Air Force relevant and other tasks are kind of like this. In the interest of time, I'm not going to really go through how the predictive performance equation actually works. I'm just going to throw it up on screen here, just so that it's there. For people that are familiar with these kind of memory models, the point is that it's basically the memory strength is modeled as like a latent aspect, kind of like an ACT-R. For people less interested or familiar with this, the point I want to highlight is just basically the green aspects of the input to the model that are the timestamps. When does something happen? We have a number of free parameters in yellow that we're estimating and trying to get that as close to the observed performance in blue. It's not that visible, sorry. That's kind of the point, right? We know when something happened, how they performed back then. We're trying to get the model as close as possible to that and then project outwards in time. All right. Now, quickly, the studies we've gone through so far, that we've done so far, I'm going to race through these. There's a really large field study. This was a large effort undertaken in which we studied nursing students. So these people, part of their training. The empirical results are published in these 2 papers. This is basically focusing on acquiring the skill and retaining it. There were a lot of learners across 10 different sites, and we manipulated how frequently were they exposed to the skill as they were training it for 4 sessions. And then there was a kind of a projecting outward where the retention intervals were either fixed, 3 months or 6 months, or predicted by the model. What we found in the study is that the model was really good at predicting when someone should come back. The variance was lower for the predicted scores, suggesting that we were pretty good at predicting when they should come back. Then we also did a simulation study on these data after the fact to kind of ask ourselves, could we have done better, right? Could we have had a better model? And we basically set up the simulation study in which we compared different variations of PPE. So we just took the data, we tested different variations of PPE, or we tested different machine learning models, or a combination of both. Again, sorry, I'm just going to race through this, but what we see is by comparing these 29 models, the model that we actually used in the study was in the top 10, so it did pretty well. The original model combined with different machine learning models did better, so there's room for improvement there. And the best model is kind of an adapted version of the PPE with a random forest. And this profile version of PPE is actually based on an idea that is kind of the actual topic of this talk, if you go to the conference proceedings, where we basically looked at some clustering. So we did a simulation study on these data, the baseline to baseline kind of data. And essentially what we see, I'm going to just give you the rough details here, is that we can basically, sorry, let me make sure this stuff is on the screen. Yeah, so we basically, we showed in the paper, and you can see the details there, that a fairly small number of profiles like these, like here we have 3 kind of different performance profiles, were actually a pretty good way of predicting how well someone's going to do on the second profile, especially if we use fuzzy memberships. So you are not specifically assigned, you are definitely one of the red profiles, but you can be fuzzily assigned to these. So that worked really well. Then there's a quick study here, I'm just going to mention it, that showed that when you bring in people that have prior experience, so these are students, they come in and they're terrible, right? 2% of them can actually do the task if you just give a mannequin. But if you give them a quick refresher, they shoot up. Like the skill is reinstantiated really quickly. So this provides some evidence for this idea of low dose training. Also, I like the title that we came up with, but that's besides the point. Now, where do we want to go with this in the future? So this is kind of like what we've done in the last couple of years. Again, the goal is to get people to be consistent and proficient whenever they show up. There's a lot of individual variance. So the one size fit all kind of approach that is currently done, right? Everyone, every quarter won't cut it. So what we need to do moving forward is we need to reliably identify individual differences between the people. We need to develop a predictive model that we can use to forecast when someone should come back or when they need more attention to train, right? And ideally, this model isn't just some random black box machine learning model, but has cognitively relevant and interpretable parameters in it so that we can communicate to the stakeholders or to the learners, hey, you need to come back because, for example, your estimated learning rate is pretty low, that kind of thing, right? Maybe more nicely framed. And then, of course, this is kind of not a cognitive science. So I hope you appreciate that the first 2 points are kind of a clear cognitive science kind of challenge. Deploying this kind of whole thing at scale in hospitals is not a cognitive science challenge, but the largest practical challenge. So what we're in the process of doing now is we're working with a candidate hospital in the US that is, they are part of the RQI program. So these are people that are already in the system. So we convinced them to give us access to a couple of them. And we're going to run a study that is going to run for about 1.5 years. Hopefully, we'll see, maybe 2 years. You know, this is all very slow. So this all happened over the last 10 years because the trainings are so infrequent. What we're going to do in this study is we are going to vary a couple of key components. So first of all, we're going to use a model again to tell people when to come back, see whether that works in real settings in a hospital. And then also we're going to make it so that at the beginning of every quarter, you do a baseline to make sure that we can track the actual performance. And then also, I haven't spoken about this explicitly here, but we're also going to randomize the order of the skills because now it's fixed. So people do the skills in the same order every time. And we're not sure whether there are carryover effects and whether that's really the best way to do that. The feasibility and the logistics of this are going to be an absolute nightmare. The cognitive science part is the fun part, but the main challenge is going to be to actually get people to do this. All right. With that, I'll leave you with this very brief overview of this project. I want to thank everyone involved in the various organizations that have contributed to this. And I want to thank you for your attention, and I'll be around for questions.